Hi there, welcome back to my video. So this will be my third video for the series of three-phase electrical system. So this video is about the sequence. What is the sequence is actually about? It's about the phase of the three-phase. Phase means angle. Each angle for each phase of the three-phase system that we have combined. Initially, if you remember in the first video, I have mentioned that the three-phase system is actually a combination of three-phase supply, three supply into a single supply source. So we are combining three sources into one. So each one of them is apart by 120-degree angle. So how do we represent this in a diagram? So let's look at it. Okay. So for the first method, we should assume the diagram should be rotated anti-clockwise. Bear this in your mind all the time. Okay. So let me zoom in. So if you look closely, I've drawn this diagram as starting from here. Okay, we just look from here, A, B, C. Okay, A, B, C. This way, I've plotted a dot here along with the eyeball, which shows that you should assume you're looking from this direction. Okay, you are looking from the eyeball direction. Okay, if you rotate the three lines, assume this is the point. First line that would touch the point will be this line. Okay, in this case, let's say I name it A, B, C. A, B, C. So if I assume my point is here, if I rotate it anti-clockwise, okay, for me this is anti-clockwise direction. Okay, so if this is the point, the first line to touch the point would be the point line A, followed by B, followed by C. Okay, same on the other side. For the negative sequence, it's the opposite actually. So actually it's the same diagram, just the labeling is different. Now I label it as A, C, B. Remember, lock the rotation direction. In this case, I assume anti-clockwise direction. Just choose one direction. You either choose anti-clockwise or clockwise. It goes the same. Just that you have to fix one direction. Okay, I assume as anti-clockwise direction. Okay, if I assume anti-clockwise direction with ACB, and I put my point here, when I rotate anti-clockwise, my A would touch first, followed by my C, followed by my B. So the previous positive sequence, my A would touch first, followed by B, followed by C. On the negative sequence, it becomes A, C, B. That's the concept actually. That's it. Okay. I will explain the degrees of angles in the later part. So we have to understand the concept in depth actually. So it not necessary. It always begins with A. It could start with B, C, A. It comes the same because. Okay, let's do it this way. Okay, simple. A, B, C, A, B, C, A, B, C. Let's say I start from B, and it should be B, C, A, B, C, A, B, C, A, followed by C, A, B, C, A, B. Means the initial point, or in terms we call it as reference point, becomes your reference voltage in terms where you are referring from. That is the actual reference point where we vary the voltage actually. So we have to consider the next two voltages based on these reference points. In this case, the magnitude will stay the same, just the angle will be different. Okay, let's look at method 2. Two ways to draw the sequence. I'm giving you both options. It's up to you how you want to understand. Okay, it's up to you. So method 2 is fixed diagram, just a fixed diagram. You can't change the alphabets in any order, just fix it the way it is. Okay, each one of them is separated by 120-degree angle, A, B, C. Okay, but in this case you have to memorize that negative sequence is anti-clockwise and positive sequence is clockwise direction rotation. This is very important. Okay, please bear in your mind and remember it when you are solving any three-phase problems. Okay, in this case my reference point I've placed before the A, so the reference point becomes the point of contact with the line. So in this case I fixed my point A, B, C. So A, B, C, my reference point is here. So if I rotate it anti-clockwise, okay, this rotation is anti-clockwise to me. Okay, so you hold your hand like this and make it yourself so you can understand it practically. How does it work? I mean the shift of angle in three-phase system. So if you rotate it anti-clockwise, A will come first, followed by B, followed by C. About the other side, the opposite way, clockwise direction, B, C, A. That's for clockwise direction, which means A, B, C is for positive sequence. CBA or CBA is for negative sequence, isn't it? As I told you before, it could be ABC, BCA, CAB for positive sequence, and negative sequence it could be ACB, CAB, BAC. So please, I know it's quite confusing. Take your time, please pause the video if you feel it's too fast and review it back again. Okay, just bear in your mind negative sequence anti-clockwise direction, positive sequence clockwise direction. Okay, that's about it. You may ask, why does it require 120-degree angle of shifting for each phase? As we all learned before, a circle consists of 360-degree rotation. Therefore, when we are using a three-phase system, each system should be equally divided and contribute equal amount of phase shifting. In this case, for three-phase system, we have to equally divide the 360-degree angle by 3, which gives you 120. Therefore, we use 120 degree of rotation shifting for each phase, but bear in mind that the magnitude remains the same. Right? Let's go to the properties. Okay, this is a very important, it's really crucial fact that you should remember always while you are handling three-phase system, which is the properties of star and delta connection. Here I've simplified the concept, so I've tabulated the formulas in a short box, so please jot it down, look it back again and again so you can remember it for quite a long period of time. Alright, so if we look here, look closely, for the Y connection or the star connection, the voltage E line is equal to 3 square root times E phase times with angle 30 degree. Current will be I line, current of line is equivalent to current of phase. Meanwhile, for the delta connection, voltage of line voltage is equivalent to phase voltage. Whereas for the current of delta connection, line current is equivalent to 3 times with phase current with shifting angle of negative 30 degree. Please consider this angle to get accurate results, because some of them have habits of ignoring the angles, so it may cause inaccuracy in your calculation. So I would recommend you to please consider the angles while you're calculating. Okay, so always represent your answer in polar form. So usually in calculation we will be using a rectangular form whereas we should be converting into polar form in the final answer. Okay, here's the three-phase voltage generation and the phase sequence which we could actually observe if we are using oscillator. Okay, here they have used a positive sequence, and here's the results that we could obtain from oscillator. If you connect three-phase system to oscillator, this is what you could observe in the oscillator. Okay, where the first touching line for V, which is the VA, starts with 0 degree shifting, followed by the VB, which is 120 degree shifted, and VC also 120 degree shifted from the VB. Okay, now let's go to the theory calculations. Okay, let's look with example to give you a better understanding. In this case, I will be using method 1. Okay, so if you look here, I've written the reference voltage. Usually the questions will be somewhere like this, where they have given you one reference voltage and you should figure out the rest by yourself. Okay, so in this case, since I have labeled it with a capital letter, we assume it's a generator. Okay, we assume it's a generator. EAN is given, which is 195 volt with 0 degree phase shifting. So they have given us EAN. So let's figure out EBN and ECN. Okay, EBN would be 120 degree shifted from EAN. So it should be 120 degree volts. ECN would be 120 degree plus 120 degree, which will give you 240 degree. There's another way to write this. Okay, so EBN is the same way, but for the ECN you have an alternate way to write it. If you look here, C, the line C is actually negatively 120 degree from line A. If we assume this is 0 degree, and this, if you assume this one as a positive rotation, then this will be negative rotation, isn't it? So the negative angle, the angle will be negative 120. So in this case, ECN can be also written as negative 120 degree voltage. See, simple as it. So this is one of the exercise. So please try to do this question, and I will post the answer in the comment section. Please check with it to test your understanding. Okay, I hope you have benefited from this video, and if yes, please leave a like, subscribe, and please feel free to ask your questions in the comment section. If I'm free, I will definitely respond to your questions. Okay, thank you so much.